and you won't notice it otherwise. All right, today, guys, we're going to talk about inverses. Now, you did inverses in Algebra 2. The most common ones were trig inverses. Remember when you said sine -1? If you had an angle, you did, and don't write this down, you had an angle of 30. You said, you put in your calculator, sine 30, and it said 0.5. Then sometimes you had the sine, but you needed the angle. So you said sine -1 of 0.5, and it came back and told you 30. This is an inverse. We do this for inverses. We also took your sine curve like this. If you remember, we cut it off here, we restricted it before it turned, and then we only use that domain in that range. Sine curves are the easiest to see for a function, but every function that passes a one-to-one function test, a horizontal and a vertical line test, has an inverse. If it doesn't pass a horizontal line test, it just has a reflection. Now, the nice part about this, we can see it when we graph this. If you take a look at a function, you should be able to tell, is it going to pass a horizontal line test? My inverse will pass and be a function. Your goal of finding a function, vertical and horizontal. It passes a vertical to be a function, but it passes a horizontal to be an inverse function. If it doesn't pass a horizontal line test, then it's not a true inverse. It'll still be a reflection over the line where you don't show up on this. The only thing that does is, my board, if you ever looked at the Moodle, it's just the board. That's all you see.
Well, I didn't want to interrupt the class.
You won't. I'm sorry. You're fine. All right, now, the way we find an inverse is one simple rule. A reflection over the line y equals x. Now, here's my line y equals x. It's also called an identity line, or a linear identity, because all the points have the same x and y. 1, 1, 2, 2. See how they have to be the same, right? -1, -1, -2, -2, -3, -3. It just cuts that quadrant right here. It's a line that goes through both of those quadrants. If I had the point 1, 5, and I wanted to reflect it through this line, what would this new point be? No, we're in quadrant 1.
Oh. 1. Wait, what are you asking?
What if I had this point 1, 5, and I reflect it through this line? What will this new point be using those numbers?
5, 1.
5, 1. Ah, so your rule says take the x, y, and swap them, interchange them. We just interchange your x and your y. And that's exactly what this says. By interchanging the x and the y, you can form the inverse of your function. So if I have this line here, this line over here says x plus 4. Here's my line, x plus 4. If I took the points off of this line and I swap them around, I interchange them. See me interchanging them? And you need this for Algebra 2 as well. Now I have a whole new set of points. When I graph this, this will look like this. Can you see the reflection over the line y equals x? Can you see its reflection? It's like I folded it right on that line and it came out. If every x is unique and every y is unique, it makes it a one-to-one function. No x repeaters, easy way. No x repeaters, no y repeaters. You cannot repeat the x or the y to be a one-to-one. Because what happens is, here's my original. When I do a vertical line test, it's a function. When I do a horizontal line test, that means this one passes its vertical. So I can do the two tests on my original function and know that I will have a true inverse. Not everything has a true inverse. If I drew a parabola is a function, it passes a vertical line test. Does it pass a horizontal? No. When I draw this one, it's going to actually look like this. Oh, and that does not pass a vertical line test. On Friday, we're going to restrict this domain and take one of these legs off, and then only work with the partial one. We're going to force it to become a true inverse. On Friday, we're going to restrict the domain. But right now, we don't have to restrict your domain on this one. Now, when you go find this new equation, you follow a simple set of rules. You take this equation, which is the sheet that I gave you. I gave you this sheet. I'm going to follow these steps with this one. I'm going to take this equation. I'm going to replace the f of x with y. Then I'm going to interchange my x and my y. That's your rule, right? Interchange. And then, like all your equations, you solve for y. So I'm going to subtract 4. X minus 4 is equal to y. And then, like it says in the last step, take the y and replace it with f of negative 1 of x. That's how we tell it this is an inverse. You know how you do sine to the negative 1? Sine to the negative 1 is your inverse. F to the negative 1 is our inverse symbol. The one on this paper is a little bit more involved, but it's the same process. You follow the same process every time. So isn't that what they came out with? How to get their new function? Right? Now your calculator draws inverses for you. But it doesn't, it only draws a true inverse. It doesn't know how to restrict a domain unless, of course, we tell it to. But it will draw you an inverse. And we're going to take a look at that in a little while. Now, the next part about this is also this one right here. Here's my f function and my range of my x function. My domain is my x's. My range is my y's. When I swap them, interchange them, my domain now becomes this guy's range. And this will swap around to here. We're going to see that in a minute. Don't you see it here? This was my domain. My domain for this guy was 1, 2, 3, 4. My range for this one was 5, 6, 7, 8. Let's find this one. My domain for this guy is 5, 6, 7, 8. Ah, isn't that my range? Because you take every x and you make it be a y. So x is the domain. If you make it a y, it becomes this guy's new range. And his range will be 1, 2, 3, 4. So all your things swap. Domain and range have to swap as well. So that's what we're looking at when we look at inverses.
So as soon as like on the function, like the operation is opposite, we know that it's going to be an inverse.
If it's an f to the negative 1.
Like we know how the function for the first one was x plus 4.
Yes.
And the one x.
Oh no, it doesn't always end up that nice.
Okay.
Yeah. If you take a look at the one that I gave you on your sheet, this one, this guy, let's follow this one through. F of x. This is how to find algebraically how to find your inverse function. Now notice it says write the original equation. Then the second step, it says replace f of x with y. You can't interchange them if you don't have a y. This is our y. Now it says interchange these. Good so far? And it says solve for y. We add 4. Now they just flip these around. They use a reflexive statement. When we do a square, we square root it. When we do a cube, we cube root it. So y is equal to the cube root of x plus 4. Now, you have a calculator handy? Put this in your y1. Put this in your y2. And put y equals x in your y3. You should see the symmetry. This was a cubing function that had dropped 4, so it went like this. It passed both a horizontal and a vertical test. Cube root, go to math, come down to the cube root. See it? Now this one somehow goes squiggly like this somehow. But you should be able to see the reflection over the line y equals x. And you should see that your new function does in fact pass a vertical line test. This new function is in fact a function. Right? See it? If you do a zoom 5, it looks better. Do zoom 5. If you do a zoom 5, guys, it takes that distortion out. It gives you a square look. Even though it's still oblong, it gives you a square look. It takes the distortion out. Now, since you have your calculator handy, Bailey, in your first one, where it says x and y1, give me one pair. Just give me a pair. -1, 5. -5? -1, -5. Now, did you put that in y2, your new one? Okay, but now, when this says -5, this should say -1. True? There's your swap. Interchange the x and the y. See them interchange? They interchange. Everything about an inverse changes. Your x and your y's interchange. Your domain and your range interchange. It's not easy to see the domain and the range interchange here because your domain and your range are both all real numbers. And they continue to be all real numbers. Okay? Alright. Now, here's a little test. If you remember back, remember one of the last homeworks we did? You did f of g and g of f, and then it said were these equations the same? And the first problem they were not. The second problem they both equaled x. And I said that leads us into our inverses. Well, if you can do f of g and g of f, and they both come out to equal x, your identity line, they are true inverses. But they have to work both ways. It has to work f of g, and it has to work g of f.
If they come out to the same thing?
If they come out both say equal x. Because y equals x is your identity line. So let's try that. And I know these look bad, but they work really nicely. So we're going to take g of x, that's a cube root, and we're going to plug this into your f of x. We're going to take this side and plug it into this x. 2 times the cube root of x plus 1 over 2 cubed minus 1. When you cube a cube root, it's the same thing as when you square a square root. It just pops out. So we get 2 times x plus 1 over 2 minus 1. When you multiply this, what happens to your 2's? Cancel. So you're left with x plus 1 minus 1. What happens to your 1's? Cancel. And you are left with equals x. That's your identity. Y equals x. So that's one half of it. Now we've got to check the other half. You're going to start with your f of x. You're going to put it into your g of x. It looks bad, but it's really not that bad. So we're going to take this whole function and replace just that x. See it? Slide this into there. So we're going to get the cube root of 2x cubed minus 1 plus 1 over 2. What happens to the negative 1 and 1? Cancel. What happens to the 2's? Cancel. What's the cube root of x cubed? X. So, they both equal x. If they both equal x, then they are inverses of each other. And you should be able to put 1 in your y1 and 1 in your y2 and see, in fact, that they are inverses of each other. They will have to work that way.
So on the test, are you gonna ever make us do this? Like,
You might have to. You might see it on homework. You know, tell if these are inverses of each other, do g of f and f of g. If they come out to equal x, then they are.
I should stop here real quick.
Absolutely.
you know, radical right here, does that say 2x cubed minus 1?
Okay, next part. We're going to find the inverse of this, just the equation. This is a line. Does it have a domain restriction? It's a fraction. No, because why? There's no x. Very good, Aquila. That was really good. Because everybody sees denominator and says yes. There's no variable in the denominator, so there's no domain restriction. So we're going to get a line. Now, we're going to take this and we're going to follow our rules. Replace this with a y. Interchange the x and the y. Good so far? So I got to solve for y. So I'm going to cross multiply this mess. Got to get y by itself, so I'm going to subtract 5. And divide by negative 3. So I'm going to get y is equal to 2x minus 5 over negative 3. And the last thing I want to do is give it the inverse symbol. Change the y to f of negative 1 of x. Now, if I graph my original in y1, and I graph this in y2, I should see all the rules of reflection over y equals x. I should see the symmetry. I should be able to take one point and swap it. I should see my domain go to my range go to my domain, but again, they're all real numbers, so you're really not going to see it. We will in the next one, yes. No, you have to do it after. You can graph this and see what it looks like and probably sketch it off of your graph, but you can't find the equation for this. Now, let me show you something. These are steps to graph, and I'm going to graph this with you in a minute, but just bear with me for a second. I want you to come here, and I want you to change this one to the one underneath it, to the one that looks like this. Because this is where you're going to see everything about your true inverse. Yeah, change that. Because we keep doing all the domains and the ranges are the same. This one you will actually see the difference in the domain and the range. What is our concern with this function? Square root. We got a restriction, right? So what can it not be? Can't be 0. Can't be negative. So we take this out and we set it greater than or equal to 0. It cannot be 0 if it's under a denominator. So we add 3, divide by 2. So our domain is 3/2 to infinity. Agreed? So why don't you put this in your calc and bracket for us? See if we can sketch this. Put it in your y equal, this original one that I changed for you. Put it in your calculator. I would, but I can't pull out my calculator. They forbid me.
Do you have a license to this
I'm
calculator?
gonna have a license to carry a concealed calculator. Now, look at your graph. What's missing here? You should start at 3/2. Do you see your graph come down to your x-axis? No. It's got a little gap. But that's not your problem, it's your calculator's problem. You know you should start right here and go like this. Because we took a look at your domain. So your calculator looks like it starts a little bit above the x-axis, doesn't it? So we're going to check this number. Because it's 3.5, 3/2, 1.5, I can't really see it in my table unless I change it. So go second calc and hit enter for value. I'm going to put in when x is 3/2. Just say 3 divided by 2 and hit enter. So what's the y? 0. Do you see now where that little bug is? It's right down at your x-axis. So it really does start right here. So this is our domain. What is our range?
0 to infinity.
Good. 0 to infinity. Very good. Does this function pass a vertical and a horizontal line test? Yes. So this is a 1-to-1. It passes a vertical and a horizontal line test. We checked both. So now we're going to convert our equation. We're going to interchange the x and the y. Yes. The horizontal line test? Here. This does keep increasing. Slow.
Yeah, but I thought it was a test of more than one check.
This is a vertical. Horizontal means this way. But what happens in your graph is you really can't see it. Your graph almost looks like it flattens out, but it really doesn't. It's forever. If you look at your table, go to your table. Do you see the y value constantly increasing? It never sits at 1. It just increases so slowly. Just slowly. So now, we got to get this out of this square root sign. How do I undo a square root? Square both sides. This is your radical. I isolated my radical. See how all these things we did in the first unit keep coming back at us? X squared is 2y minus 3. It pops right out. So I add 3, and then we divide by 2. Now, last thing, change this to your inverse notation. Now, here's the problem. What does it say it's going to give me with an x squared? Parabola. But I don't really think that I'm going to end up with a parabola. So I'm going to go to my table for this guy. I know it starts at 3/2. That's the 0. Pull out a few points from your table. I'm going to graph this myself and see if it's a parabola. What other points can you see without the decimals? Like 2, 1, right? What other points can you see on your graph?
Which one? The inverse?
No, just this one.
1, 3, 6, 3.
6, 3. Okay, we'll use these. This is this one. Now my inverse says I should swap these, right? My inverse says swap these x and y's. So this should become 0, 3/2, 1, 2, 3, 6. Agree? I'm going to graph this guy. 0, 3/2, 1, 2, 3, 6. Up here. It's going like this. Is that parabola? No. Now, this is what I want you to do. I want you to graph this in your y1, and with parentheses around this numerator, I want you to graph that in your y2. Because this is telling me that this is the function.
Why do you have to have parentheses around the
Because in your calculator, it will do this divide first. If you do this, it will do this
Oh.
first.
Oh, yeah, yeah.
Yeah,
So
so,
you can type it as an actual fraction.
oh, you're going to use a fraction
Yeah, like
bar.
alpha one.
As you use a fraction bar, that's fine. Yeah, sorry. Now, notice that gives you a parabola. That gives you this piece over here as well. We don't want that piece. We only want this piece. So what we have to do is tell it. You know you're only taking those points and swapping them. So we're going to finish this rule. The rule says interchange all the x and y's. This domain becomes this guy's range. This range becomes this domain. So we kind of have to restrict our domain to this. Isn't that true? From 0 to infinity? I only want this piece. I only want the red line up there. I don't want the parabola. I need that equation to get to that leg, but I have to restrict my domain. It comes from here. The range becomes the domain becomes the range. See, I gotta tell it just from here to here. Don't give me that whole parabola. Okay? Alright, hang in there. One more thing, one more step. Now, your calculator will draw an inverse, but it won't give you an equation. So, if you come down here, one more thing, we're going to come down here. What I want you to do before you start is just put this one in your y1, make sure there's nothing else in your y's. Put that in your y1. And then I want you to do, tomorrow we're going to do a whole activity on this actually. I want you to go to second program. So it's right under like stat delete, there's a program word. You're really using the draw. I want you to do number 1, clear draw. Clear any drawings before you start. Just click that. Now, let's go back to that again. And now, come down to number 8.
Wait, now go back to the
Second program. Come down to number 8 where it says draw inverse.
Oh.
We're going to tell it to go to my function in y1. That's where your function should be. So when you come down here and it says draw inverse, you need to tell it y1. By doing that, you say go to VARs. It's right by the clear button. Scroll to the right to the y VARs. Hit 1 for function. Just hit enter. And hit 1 for y1 until you see that y1 out there. Hit VARs. Go to y VARs. Hit enter, enter. Now, hit enter. It's going to draw this. It's going to draw this, and then it's going to draw this. It didn't draw your whole graph. Oh, because it took it. You know, what happens is when it clears, it's probably didn't do, you got to hit enter to say done.
Oh, I didn't do it.
Yeah, so now go here to number 8. Then hit VARs, y VARs, and then it'll draw. It'll draw this guy. See it draw? See it draw the correct one? That's your correct inverse. Your calculator is very bright. It only does the correct one. It can't do an incorrect one. So your calculator knows, don't take that part of the parabola. I just need this part. So tonight,